This is Learning Target Check 1. This is, I'm going to go through the answers so you can see where you went right and where you might have went wrong. So for the first question I was asking, what's the difference between an endothermic reaction and an exo? And I was looking for a couple different things. Endothermic reactions, energy is going to be required to make that reaction happen. When you write it in a chemical equation, it's going to be written as a reactant. And when these reactions occur, you're going to see a decrease in the temperature of the system. Exothermic are kind of the opposite of that. In an exothermic reaction, energy is going to get released. We're going to write it as a product because it's being created. And these, the temperature would go up. So this is like you can think of when you have one of those Snap ice packs. You make the chemical reaction happen and the temperature goes down. And this is like a hot hands pack where you shake the chemicals together and the temperature goes up. All right, moving on. Now we're going to use this chemical reaction to calculate some energy changes. So I'm seeing a chemical reaction here. The first thing I want to do is I make sure it's balanced. And it's already balanced. The numbers are already there for me, so I won't have to do that step. I'm being asked if the chemical reaction is endothermic or exothermic and explain why I know this. Well, I just said up here that endothermic reactions, energy is written as a reactant. So since I have my energy here, I know that this is going to be an endothermic because energy is a reactant. The energy unit here is kilocalories. So we've been using joules mainly in our practice problems, but kilocalorie is just another way to measure energy. Okay, how much energy is used in the reaction if 12.5 grams of iron are produced? So we're going to set up our little chart so that we can compare moles of iron and energy. So in the reaction, there are 4 moles of iron. And when 4 moles are produced, that uses 110.8 kilocalories of energy. I want to know how much energy is used if I have 12.5 grams. So 12.5 grams of iron. I'm going to divide that by the molar mass because I want to get into moles. And when I do that, I end up with 0.224 moles of iron. Last step here is I'm going to cross multiply and divide. So I would take 0.224 times 110, divide the whole thing by 4, and I end up getting 6.20 kilocalories of energy used in that reaction. Next question on here is asking about carbon dioxide. So it's the same type of question, setting up our energy comparison. So we're going to do moles of CO2, carbon dioxide, and energy. My top of my proportion comes from my chemical reaction, which tells me that for every 3 moles of carbon dioxide made, 110 kilocalories were used. So 3 moles, 110. And then I'm going to go back to the problem, and it says, how many grams will be formed if 235.8 kilocalories is used? So 235.8 kilocalories, go down here. I know I'm going to get more than 3 moles because I'm going to use more energy, but I need to figure out moles first. Adjust my paper. For this one, I'm going to take 3 times 235.8, divide it by 110, and I get that that would give me 6.384 mole. The problem doesn't want moles, it wants grams. So my last step here would be convert from moles 2 grams by multiplying by the molar mass of carbon dioxide. And when I do that, I get 280.9 grams or 281 grams. The sig figs on this one is weird. I'm gonna leave it like this, 280.9. Sorry, my kids are in the background. All right, last question on here. Maggie, sweetie, please be quiet. Okay, last question on here is talking about specific heat, and more specifically, trying to figure out what the specific heat of aluminum would be. So how much energy is required to raise that aluminum, 1 gram of aluminum, 1 calorie of energy. So the formula for specific heat is going to be that energy is equal to the mass, the constant, and the change in temperature. So this C value, that's specific heat. That's what we're trying to find. So I'm just going to pull out of the problem the numbers so that I can solve for C. So first number I have is 457 or 4,750 joules of energy. So I'm going to plug that in there. Nope, I don't need any help right now. Also, you're 2, and I don't know if you can do chemistry yet. You can sit by me though, just sit quiet. Sorry guys. So I'm gonna take that and then I'm gonna keep reading, and I'm getting that there are 249 grams. So that's gonna be my mass of aluminum.
You make cake.
I don't know the C, and I know that my temperature changes 21.1 degrees Celsius. I like to put everything in parentheses just so I can see the difference. And then I'm gonna solve for C. So I have to get C by itself on this side. I'm gonna divide both sides by 21.1. This is gonna cancel out. I'm also gonna divide by 249. This cancels out. And I'm gonna do the math over here. And the math over there gives me a final answer of the specific heat of aluminum is 0.904 grams degrees Celsius per joule of energy. So hopefully looking at that can help you go through your work and figure out what you might have done right or wrong on your learning target check. Talk to you later.